So a person leaves their home and walks 500 meters west. They then make a 90-degree left turn and walk 1 kilometer in that direction. They then turn 45 degrees to their left and walk another 200 meters. So part A, it's asking us how far is the person from their home. So in order to do this, we're probably going to need to draw ourselves a vector diagram, and from that we should be able to make this calculation. So this is like a compass, north, south, east, west, and I'll draw, this is like the home of our person. Okay, so they're going to leave their home and walk 500 meters west, so that's this direction, alright, west, and I'll put this as 500 meters. They then make a 90-degree left turn, so if they're facing in this direction and turn left, that's going to be downwards, and they walk 1 kilometer in that direction. So let's draw that in. Let's keep the units consistent. So 1 kilometer, that's going to be 1,000 in meters. Right, they're now going to turn 45 degrees to their left and walk another 200 meters. So if you're facing down this way and you turn left, that's going to be towards east, and it's a 45-degree turn. So that means that this angle in here is going to be 45 degrees, and that was a 200-meter walk. Alright, so the question is asking us how far the person is from their home. So we could draw a vector for that. It's going to be where they started, all the way out until where they ended. And this is kind of like the resultant vector of adding together these three kind of displacements. So what we can say then is R is going to be equal to, let's give these names. So let's call this one, say, S1, S2, and S3. So R is just going to be all of them added together. Okay, that's the definition, of a resultant. So it's going to be S1 plus S2 plus S3. Now to be able to add these together, we kind of need to express all of these different vectors in their I, J, K form. So that's going to essentially mean working with your X and Y coordinate system and rewriting these out. So let's start with S1. So if I'm using this regular XY coordinate system, this is going to be in the negative X direction. So I can write this as a minus, and it's 500 long, and it's an I since it was in the X direction. Alright, the next one here, S2, we can see that this one's just pointing downwards, which is in the negative Y direction. So we could write this as negative 1000J. And then this last one is going to have both an X and a Y component. So I can draw out the triangle if that makes it a little bit easier. So we know that the length of this hypotenuse side is going to be 200. Try and make this look a bit more vertical. And then we've got an Y component plus an X component that needs to give that 200. And we know one of the angles, that's 45 degrees. So let's call this S3Y and S3X. So if I start by doing cos, say, of 45, that's going to give me the adjacent over the hypotenuse, so S3Y on 200. And this is going to work out to 141.4 for the length, so 141.4 meters downwards. And then if we repeat this for sine, it's equal to the opposite over the hypotenuse. And since it's a 45-degree triangle, we would expect that S3x should work out to the same value, so 141.4. So now we just need to write it in vector form for the S3 one. So it's going downwards in the Y direction, so that means it will be a negative. That's 141.4, and it's J. And then it's in the positive X direction, so plus 141.4, and that'll be I. Alright, so now these three vector expressions that we've made need to get substituted into our resultant equation. So we're going to get negative 500I plus negative 1000J plus our final vector. Alright, so now we put the I components together, so negative 500 plus 141.4. that leaves us with negative 358.6. And then for the j's, we have negative 1,000 minus 141. And that leaves us with this. Alright, so that's like the vector that kind of describes the resultant, but what we were really looking for was how far they are from home. So what we're looking for is just a number for the distance that they are from home. So that would be then the magnitude of this vector, or the length of this vector. So we can get that fairly easily. Whoop, went through, there we go. So it's just a matter of putting it into our square root. Oops, sorry. Like so. And putting that in a calculator, you find out that the person is 1196 meters approximately from their home. Right, so for part B, if they were to walk in a straight line home, what angle would you advise them to walk at, measured from due north? So this is where they're at, this is where they need to be. So a straight line is basically just going to be the opposite of this r vector. So I'll just pop it in here. Alright, that's the vector that they need to walk on to get home. So what we're interested in is the angle that this vector is at, measured from north. So that's going to be the theta I've marked in there. So let's draw ourselves the vector kind of triangle that we can form for that blue vector I've marked in. So the length of it in terms of the y direction, well, it's going to have the same length of this r vector, it's just the opposite direction. So rather than being negative, so downwards, it's just upwards that amount. So it's going to be 1141.4. And then for the horizontal component, same thing. So ours, for the blue one, is pointing to the right-hand side, which is the positive x direction. The green one, which is what we previously worked out, was just the same amount, but to the left. So we can put this as 358.6. So this is the theta that we wanted to find. So now we should be able to use sine, cos, or tan because that's a right angle triangle. So I'm going to use tan since I've marked in as the opposite and adjacent, but of course if you wanted, this is also the 1196 meters that we worked out before, the magnitude of that line. So if I'm going to use tan, that means that tan theta is equal to the opposite over the adjacent. So solving for theta, it's just going to be tan inverse of that amount. And we can solve that. Comes to 4.5 degrees approximately. So that would be the answer. So you might want to conclude it as north 4.5 degrees east is the direction that you want to walk in. Alright, so face north and then turn this far toward the east direction. So that's all there is for this video, and I'll see you in another one.